Alright folks, this chapter we're going to talk about the different transformations that we can look at in geometry. So before we get started, what I want you to make sure you have out is your geometer or a straight edge, a pencil, and then highlighters, 3 different colors. Okay, if you need to borrow some highlighters, drop by my room and then I can lend you some. It's going to be important for what we do today. Alright, so now what we're going to focus on today is only reflections. Okay, there are different types of transformations and a reflection is one of them. Okay, a reflection is kind of like what you think of like in a mirror. Okay, when we reflect an object, we're reflecting it over a line. Okay, and then the image in the mirror, okay, is what we call the result of a reflection. Okay, so our starting figure is the pre-image, or before what we start with, and then the image is the result of our transformation of our reflection, and we call that the image. Well, you'll notice on our first picture here it goes A, B, C towards the left, but on this one we've got A and this little marking. Okay, that means prime. So that is A prime. It's just our notation for a transformed point. Okay, so it goes A, B, C going to the right here. Because when you look in the mirror, things are all the same features, but they're kind of backwards. So the order a little bit changes here. Now, those features we're going to talk about over here. There are 4 items that are preserved by every reflection. The 4 features are angle measure. So if we look in our picture, the angles we see to start out with, they don't change size. Okay, so angle A should be the same size in each of these. Angle B doesn't change. Angle C doesn't change. Okay. B is a weird word. It's called betweenness. And it just says that if A starts out between B and C, it better be between B and C over here as well. You'll notice A is between those 2 other letters. Okay, this makes a lot of sense with triangles, but with triangles, you're always going to be between 2 other points. It's nicer to think about it in terms of like a 4-sided shape. Because if I have A, B, C, D here, you'll notice B has to be between A and C. So on the image picture over here, okay, you'll notice that B is still between A and C on that reflection. Okay, so it's more important when there are more than 3 points there. C is collinearity. Okay, so collinearity. Now this first part we've seen before. Collinear means in the same line. Okay, so what that means for our polygons over here is if AC, those points are in the line, they'll form a segment. I should see the same segment over here. So I see AC show up, I should see AC show up. Okay, again, that makes a lot more sense with a 4-sided figure. Notice there's a side AB, but there's not a side BD. So you're just making sure the letters connect in the same way they do originally. The last thing is distance. And again, that deals with the side lengths. Okay, so the distance between A and C is going to be the same distance between A prime and C prime on the image. Okay. All of this together is just a fancy way of saying that when we reflect an object, okay, you're going to have the same size object and the same shape object show up when you're done. Okay? Because the mirror kind of reverses things, the orientation will be a little bit different. Okay, you'll notice like on this picture it went A, B, C to the left, but it went A, B, C to the right over here, so that might change, but it'll be the same size, same shape when you're done. Okay. So what we're going to do is take a look at a few examples of reflections before we try to do our own reflections. Okay, so the first one is the x-axis. Okay, just to remind you, and you don't have to write this down, I just want to review some stuff about a coordinate system here because we haven't worked with graphs very much this year. Okay, if we go left and right, that is called the x-axis. And if we go up and down, that's called the y-axis. And then another really important part is this point in the middle is 0, 0. That's our starting point or our origin for a lot of things. Okay. Now, you'll notice I wrote 0, 0. In general, points go x, y. And our x, since our x-axis goes left and right, this x will tell us left or right. And this y, since it goes up and down, will tell us up or down. All right. With our ordered pairs, left will always be shown with a negative, right would be positive. Same thing with up and down. Up is positive, down is negative. Okay, so up and right positive, left and down negative. So let's go look at this first example now. We're reflecting over the x-axis. Our x-axis goes left and right. You'll see that dashed line. And we're taking our original polygon ABC here and reflecting it down to that thing. Okay, so hopefully you can see the same size and the same shape happening with this reflection. What we want to do is see what is happening to the points. You'll notice our A value here was 2, 5, but our A value here was 2, -5. Okay, what I want you to do is right beside this picture, let's just write the transformation. So the first one was ABC, just the letters in order here. And we'll write the transformation with a little arrow there. And then our image is going to be A prime, B prime, C prime. And then we're just going to make a little table below that. Our first point was A, and that was 2, 5. Our next point was B, which was 6, 4. Our next point was C, and that's 3, 2. We know that that was our original because there's no little prime notations, that little apostrophe in the air there. Okay, so our original is the regular letters. Then our image, or our result, are the prime values. A prime was 2, -5. B prime on our picture was 6, -4. And finally, C prime was this 3, -2. Now you'll notice our x values here, what came first in our ordered pairs, they stayed exactly the same. Okay, but if we look at our y column, 5, 4, 2 went to -5, -4, -2. So in general, if we have 2 points, the first, or one point, the first one here is going to stay exactly the same. So if we start with A, we keep A. But the second value in our point switches from positive to negative. So we'll write that as the opposite of B. Notice I didn't say negative B because we won't necessarily start with a positive value. Sometimes we'll switch from negative to positive. So this means the opposite of, means switch the sign. So, if we're reflecting over the x-axis, x stays the same, but y switches. From positive to negative, or from negative to positive, depending on what we start with. All right, we're going to do that the same for the next one. This is an example reflection over the y-axis. Our y-axis goes up and down here. We're going to look at our original points, A, B, C, and compare them to our prime points, A prime, B prime, C prime. So again, draw yourself a table here, and we're going to list our original points. A was 2, 5, B was 6, 4, and C was 3, 2. On the right-hand side, we're going to look at A prime, B prime, C prime. Okay, so on our picture, A prime was -2, 5. B prime was -6, 4. And C prime was -3, 2. Once again, we're going to compare our points here. You'll notice this time 2, 6, 3 2, 6, 3 again, but all of these went to negative. So that means our x value is switching signs. And then on the other side, you'll notice the y this time stayed exactly the same. Okay, so generalizing, our a value is our first thing in our pair, and our first thing in our ordered pair switched, so a would go to the opposite of a, or negative a. But b, the second piece, stayed the same, so b would stay b. Alright, so again, just like last time, okay, over here, the x-axis, the x value stayed, and then the y switched. With the y-axis, you'll notice the y stayed. Okay, so the y value stays, and the x switches signs. The next one, we're going to look at reflection being over the line y equals x. Okay, that is a oblique or slanted line. It's not one of our two x or y axis there. Okay, remember that with equations here of lines, it usually looks like mx plus b, with m being our slope. Well, if we say y equals x, we really mean 1x, so our slope is 1. So that means rise 1, run 1. So we start at 0, 0, since there's no plus or minus anything on the edge of this. So we start at 0, 0, rise, run, all the way through the graph. Positive 1 means we're increasing from left to right, and we're going to go from bottom left corner to top right corner. So corner to corner, increasing. So looking at ABC again, we want to make our table to see what happens here, because this is a lot different than what we've been doing before. So our first point is negative 2, 5. Second point is negative 6, 4. Third point is negative 3, 2. Looking at our picture for the prime, A prime is 5, negative 2. B prime over here is 4, negative 6. And then C prime is 2, negative 3. So I'm going to look at my x's again. And I have negative 2, negative 6, negative 3. You'll notice, if I look at my x's over here, I don't see those numbers at all. But if I look at the second column, I do. And it's exactly the same sign. This started negative, this stayed negative. Okay, but what changed is the position. This was first, and it moved to the second in the ordered pair. The same thing happens for the other side. I still see 5, 4, 2 on both sides, but they've just traded places. So in general here, if I have the line y equals x, then my y and my x can switch places. So instead of AB, I write BA. So for this one, we say x and y switch places. So last time, the x-axis and the y-axis were switching sign. This time we're switching places, or we're switching the order of our numbers. Okay. Last one is we can also have y equals negative x. You'll notice this time we're decreasing from left to right. Okay, we still start at 0, 0, but we're going down 1, right 1, down 1, right 1. Okay, because our slope here is negative 1 over 1. Okay, so we're going down 1, right 1, all the way through. Okay, so corner to corner, decreasing left to right. Make sure it's going through 0, 0 though. Let's set up our chart, ABC to A prime, B prime, C prime. A was 2, 5. B was 6, 4. And C was 3, 2. Okay, I want you to pause the video right now, write down your A prime, B prime, C prime, and see if you can figure out the pattern here. Checking out 2, 6, 3, I do see a 2, 6, 3 over on the right, but they're all negatives. Same thing for our second column. I see the 5, 4, 2 in the first place, but they all switch signs. So here, we're combining a couple things here. Y equals X last time told us that the order changed. So it went, instead of AB, it went BA. But then, because of this negative, we also have to switch our signs. Okay, so order changed and sign changes. All right, so now that we know these patterns, what we're going to do is graph them ourselves. Okay, so we're doing this in 3 steps. Here's what I want you to do. First, put a little number 1 here. And our first step is to plot those 3 points that were given to us. Okay, so 3, remember, the first number tells us left, right, and the second number tells us up, down. So 3 is positive going to the right. 1 is positive going up. Mark that A. The next one is 4, 3. So to the right, 4, up 3. Mark that B. Then negative 5 would mean left 5. Negative 2 means down 2. So then I've got C there. Once you plot your 3 points, I want you to use your geometer to connect them. Okay, you must use a straight edge here. We're going to be neat on our graphs. And we've got a triangle. Now we'll use our highlighter to go ahead and highlight this shape in whatever color you want. Okay, we're going to use 3 separate colors for our 3 separate steps here. So this is step 1. Choose your first color. All right, then step 2 is we look for the line of reflection. And we want to put that on our graph. So y equals negative x, remember, is one of our diagonal lines because it's not our x or y axis. And it says negative, so that means I should decrease from left to right. Okay, so we're starting at 0, 0, and we have a slope of negative 1. Okay, so from corner to corner, we're going to put a dashed line through those points. Okay, so go ahead and dash that, connecting your corner to corner. Again, make sure you're using your straight edge there. And we're going to highlight that in color number 2. Now, the reason we're highlighting here is because every single picture we've looked at so far, this first picture that we started with was not going through our line of reflection. Anytime we have overlap, we're going to have our second picture also overlap onto all of this. So it gets really confusing with all those points and all those segments. So we're doing one piece at a time and making sure we organize them using the different colors. Okay. Step 3, we're going to put right below, and we're going to just now find the prime for each of these using our rule from step B, or step 2. Now remember, we just talked about this one in particular. If I see y equals x, that means the order switches, but since it's negative x, the order and the sign will switch. So instead of 3, 1, I'll switch the order and the sign. That'll become -1. And then this one goes to the second place with the opposite of it as well. The next one, the 3 has to come first, but I get a negative on it. And then the 4 has to be second, and I'm switching its sign as well. The last point already starts negative, but remember, this symbol negative doesn't mean it has to end up looking negative. It means the opposite of what it starts with. So here, I know the -2 has to go first, but I want the opposite sign, so that would be a +2. Then this -5 would go second, but I want to switch the sign for it as well. Once we have our 3 points, we can plot them. So I've got -1, that means left 1. -3 means down 3. There's A prime. Make sure you're labeling them as you go so you don't have to go back and figure out which point is which. The next one, left 3, down 4. And then C is 2 to the right and 5 up. Now what we're going to do is go ahead and connect our points. Oh, let's fix this. Sorry, my second one should be at -3 here. I only went over 2. -3, -4. That looks a little bit better. Now, the reason I knew something was a little bit wrong is why we're highlighting this as well. Do you see the distance here is short, but it was down 2, right 1, and the way I had it wasn't matching up there. Okay, so we want to make sure that when we're all done, we're seeing the same size and the same shape. Now again, it's going to be all mixed around in terms of order here, but now you'll see this triangle is the same size and shape as this triangle. Okay, so last thing is just highlight in your third color for your final shape. Alright, we're going to look at the next one now. Again, 3 steps. Step 1 is plot the points. So -2, 1 is A. 3, 6 is B. And 1, -4 is C. Connect them with a straight edge. And then highlight them in your first color. Step 2 is look for your line of reflection. This says the x-axis. Let's highlight the x-axis in a different color. It goes left and right. And then step 3 is find our new points. A prime, B prime, and C prime. All right. Remember, if it's the x-axis, the x stays. Okay, so our x values here have to stay. But our y's will end up switching. Now I'm going to pause here and go to the graph here just so you're understanding what's going on here. If I'm reflecting over the x-axis, it means I'm going to take each of these points and flop them over. Okay, so the x value stays the same because I'm still sitting at -2, but instead of going up 1, I go down 1, and that's why the sign switches on the second one. Okay, so the same thing goes for the other ones. Instead of going up 6 here, I should go down 6, so I still stay 3, but it goes to -6. And then the last one, the 1 stays, but instead of going down 4, I should go up 4. All right, so the graph can help you here when you're plotting those points. So A prime, C prime, B prime, to connect them. And you'll notice we have the same shape. It's the same size. We'll highlight it in a different color to finish our second problem here. All right, the next one. Step 1, plot your points. 3, negative 1. That's A. 7, 0. So that's 7 to the right and 0 up and down. It's right on that x-axis there. And then the next one here is 6, negative 5. So that's C. And then 2, negative 3 is D. Now, I'm going to go ahead and move here my letter A. That way it's on the outside of my polygon instead of inside it when I connect it. It's okay if you don't. Just make sure I can see where your letters are, all in the end. All right, you'll notice we have 4 points here. Instead of a triangle, we have this quadrilateral. Go ahead and highlight that in your first color. And we'll move on to step 2. Step 2 is look at the line of reflection. Okay, our line of reflection here is y equals x. Okay, y equals x is going to be one of our diagonal lines. This time it's a positive x, so we should increase from left to right. Okay, so we're starting at 0, 0, and we're increasing by 1, up 1, right 1, from left to right. Okay, so this is the diagonal corner to corner, but we're increasing from left to right. Okay, so a dashed line through those points, and then we can highlight it. All right, step 3 is find our prime. So we're looking at a rule here. It says line y equals x. Anytime you see y equals x, you have to switch the order. There's no negative here, so that's all we're doing is switching the order. So instead of 3, negative 1, I should see negative 1 first and then 3. The next one, instead of 7, 0, I'll have 0, 7. Next one, negative 5, 6. And finally, negative 3, 2. One at a time, we'll plot them. Negative 1, positive 3 is A prime. 0, 7, so that means left and right 0, but up 7 is B prime. C prime, left 5, and then up 6. And finally, left 3, up 2. We'll connect those. And you'll see we have the same size, same shape here. This is a nicer one because there's no overlapping, so you can clearly see that reflection happening with our mirror right at that line y equals x. All right. I want you to, at this time, pause the video and take care of number 4 by yourself. Okay, make sure you're doing all 3 steps, one at a time, and make sure at the end that you see the same size, same shape for your reflection. All right, so this one was the y-axis going up and down. Okay, you'll notice with the y-axis, we're just keeping the y value. Okay, so the y value going this way should stay the same. What changes, though, is the x. It flips signs. Okay, so y-axis, y stays, the other one switches. So instead of going to the left 4, I should go to the right 4. Okay, here instead of going to the right 3, I should go to the left 3. Down here, instead of going to left 2, I should go right 2. Instead of going on this last one, D, to the right 1, we're going to the left 1. Okay, so we're just switching the first sign. The second value stays exactly the same. Okay, our shape stays the same, our size stays the same. All right, last thing we're going to do is just look at a different notation for rules here without a graph. This R stands for reflection, and right below it, subscript tells us what to do. Remember, y-axis means the y gets to stay the same. So the 3 gets to stay the same, which means negative, or 4 has to switch to negative 4. The next one, y equals x. When we see y equals x, that's an order thing. So instead of 2, -1, we'll have -1, 2. With the x-axis, x gets to stay the same, so our x was -3, it stays the same, but that means our y has to switch. Because we started with a -9, that would switch to a +9. Alright, so look at the last 3 rules and try those next 3 on your own. Pause the video and then check them when you're done. First one here, y equals x means they're switching places, but negative means they switch signs as well. This one, the y stays the same, the x switches, but the opposite of 0 is still 0. Okay, you can't have a -0. Over here, y equals x, they just switch places. So 2 goes first, then the -2. Right? On your homework, make sure you're following all 3 steps like we did in class. Okay, I'll be looking that your pictures have highlighted the same shape, same size for those images under the reflection. If you have questions, let me know.